Hello everyone, my name is Dennis Raj Analaki Sagadeva with metric number older E201910235WA. The reason why I am here because I want to show how we run our simple pendulum experiment. The objective of this experiment is to study about the simple harmonic motion and motion of simple pendulum, to study the definition about the frequency, period and amplitude, and to study about the relationship between frequency, period and amplitude, length and the mass of the pendulum. Now I will show how we run our simple pendulum experiment. To run our simple pendulum experiment, we use the PHC simulation. First of all, we apply our ruler, stopwatch and period timer. So for the first experiment, we use the length of 0.1 meter, which is also equivalent to 10 cm. For this experiment, we will constant the mass of the pendulum at 1.0 kg. So the timer, and this is the period timer, so it will calculate the period timer itself by own. The amplitude we use is 10 degree. Okay, so now we'll start our timer. If you notice here, the period timer is already calculated. So in order to calculate the time taken to complete the 50 oscillation, we can times by the 50 the value that we get from the period timer. So this is the data we collected. So we increase the length from 10 cm to 100 cm. The time for 50 oscillation is collected here. The period t square data we can get from the experiment that we used for the timer, and we can square it the value in order to get the period square data. So this is the graph we get. So period versus length. So this is the graph we generated. And for the second one, the period squared versus the length of the pendulum. Experiment, we constant the length but we change the mass. So we constant the length at 0.6 meter, which is also equivalent to 60 cm, and we start the mass with 0.1 kg. So we stop the time, we start back the timer, the period timer, we adjust the amplitude at 10 degree and we start the swing. Now we can get the period timer for one oscillation. In order to calculate the time taken to complete 50 oscillation, we can times by 50 the period value. So here's the data we collected. We constant the length at 60. We increase the mass of pendulum from 0.1 kg to 1.0 kg. This is time for 50 oscillation and time period. So the graph we generated is period t versus mass. That's all for me. Thank you.
Good day to everyone. My name is Shari and I am presented with the metric number of E2019106.9. I'm here to discuss about the simple pendulum experimental result. So as you can see, there were two main variables. They are so known as the change in the mass of the pendulum, also the change in the length of the pendulum. So as the length of the pendulum increases from 10 cm to 60 cm, the period increases from 0.6 seconds to 1.6 seconds. So the graph here proves that for the changes. And secondly, we changed the mass of the pendulum, but significantly there were no changes observed for the period as the mass increased. So this correlates with the the formula for period, which is period equals to 2 pi square root of length of the pendulum over the gravitational force. In conclusion, we were able to understand that only the length of the pendulum does affect the period, however the mass of the pendulum does not affect the period. So we were also able to understand what is simple harmonic motion, which is the repeated movement of the pendulum from back and forth with maximum displacement on one side to another motion, maximum displacement on the other side. This experiment, there are three main elements which are so known as the amplitude, frequency and period. We were able to understand what are these elements all about. So amplitude is the maximum extent, frequency is the rate of refraction, however the period is the time taken for one complete oscillation. So period is directly proportional to length and frequency is independent of the amplitude. These are the co-relationship. Thank you.
Hello everyone, my name is Nurina Suha binti Muhammad Safri. For our DIY experiment, which is related to refraction of light. We name it magic switching. So the apparatus or materials that we need is just three. The first one is a bottle of water, a marker, and any paper. Just reuse any paper. Alright, so let's start.
Okay, first take a piece of paper and draw an arrow. Okay, and take the bottle, put here. The arrow is reversed. See? I draw the arrow to the right, but at the bottle, we can see the arrow switch to the left. Alright.
So, what makes the arrow switch? Okay, let's see. The bottle is in the middle, so the bottle acts as a convex lens. And that, if an object falls behind the convex lens, so we can see the image is inverted, it's reversed. So the water in the bottle bends in light. It acts like a convex lens. Where the light crosses is called the focal point. Because the arrow is behind a focal point, the image gets reversed as a light travels through our eyes.
Left, right.
So, how does the science experiment work? The scientific concept that is at work in this experiment is called refraction. What is refraction? Refraction is the bending of light. Refraction occurs when light travels from one medium to another, for example, air to water or water to air. During the experiment, the light travels from the image through the air, then through the plastic bottle into the water, and then finally out of the plastic bottle and into the air once more before it reaches our eyes. Light refracts as it passes from one medium to the next because it travels at different speeds through those mediums. Light travels fastest through air, a little slower through water, and even slower through plastic. Means that the light bends once it travels through the plastic bottle into the water, and then it bends again when it travels out of the plastic bottle and into the air. As a result, the light paths cross and the image appears to be flipped horizontally from what it appears so.